Welcome to Brain Vision.
Hi there. So for this problem, we have a rocket that has an initial mass of 125 kilograms. And we also know that it produces a constant vertical force of 1,070 and 720 newtons. And well, at first we need to calculate the initial acceleration of the rocket. To calculate this initial acceleration, we just simply use Newton's second law that states that the force that is acting on a body is equal to the mass of the body times the acceleration. So if we want to find the acceleration, that in this case is going to be the force over the mass, which is 1,720 newtons over 125 kilograms. This is equal to putting all these values into the calculator, obtain 13.76 meters per second square. So this is the acceleration, the initial acceleration of the rocket. Now, we know that there is an electrical power supply that rests on the floor inside the rocket, which we're gonna call M, and has a mass. Well, we don't know the mass, but we know that its weight is 15.5 newtons. And we want to determine how hard does the floor push on the power supply. So we first need to draw all the forces that are acting on this body. We are drawing the axis. So we know that the forces that are acting are the normal force perpendicular to this surface, the weight, and we also know that the rocket is moving upward with an acceleration a, so that we will have that the zoom, when we apply Newton's second law, in this case we only have forces in the y component, so this is Newton minus m, the normal force minus the weight. This should be equal to the mass of the mass of the power supply, which is m, capital M, times the acceleration of the rocket. So it's very straightforward to obtain that this corresponds to the force that the power supply is feeling because of the motion in the sorry this will be the normal force will be the force that the floor is exerting on the mass. So we need to solve for the normal force. So that will be mass times acceleration plus the weight. We know that the weight is defined as the mass of the body times the acceleration due to gravity. We can factorize this as follows. And we simply need to put the values of this in here. We don't know the value of the mass of the of the power supply, but we can find it just by knowing that the weight is mass times the acceleration due to gravity. So to obtain the mass, we just simply divide the weight over the acceleration due to gravity. We know that acceleration due to gravity is 9.8 meters per second squared, and the weight, we are given the weight, which is 15.5 newtons. So we put this in here, we obtain that the mass, of course, this is the capital L M mass of the power supply, and this is equal to 1.6 kilograms. And we now just simply substitute this value in here with the value of the acceleration that we obtained in the first part of this. So we will have 1.6, which is the mass of the power supply. And it is the sum of the acceleration that we obtained in the first part, that is 30.76 meters per second squared, plus the acceleration due to gravity, which is 9.8 meters per second squared. Now putting this to the calculator, we obtain 37.7 newtons, and this is the force that the floor is exerting on the power supply because it is inside the rocket that is traveling with an acceleration upward.